All right, my friends, we are going to continue on with this whole concept of adding areas, adding areas. So what do we mean by that? The actual title to the lesson is giving you the clue that there is more than one area involved that we are calculating, and then we need to add them together. All right, so again, it is about putting together everything that we know about this whole concept of area. And again, it is that space inside a two-dimensional closed figure, what that space covers, with no gaps and overlapping and a big hot mess that we've seen previously. Because remember, we always talk about what things are and what they're not. All right. And so then we talked about ways to calculate area, that we can use tiles and we can model it. We can build arrays like we're solving for multiplication facts. Always remembering that area is offered in square units and not just the solution to a multiplication fact. So for example, if we're measuring the area of a room and it's 9 feet by 9 feet, that area is going to be 81 square feet or 81 feet squared and not just 81. Always important to remember what I'm asking you, always answering that question being asked, always close reading, circling, underlining, highlighting, marking up important information, excluding the rest so you're not cluttering your brain. If there's more than one question in a word problem, number those questions. I have to do this, then I have to do this, and then I have to do this, making sure you're doing all of it in sequence and answering everything that you need to answer. We're going to keep on going with this. We're going to be taking a look at these, what we call composite shapes or combined shapes, where perhaps a larger shape is sectioned off and we have to find the area of one space and the area of another space, add them together, adding areas. Again, always in square units. All right, this is where we're headed now on page 341. In a moment, I'm going to share my screen. We're going to walk it through as we always do. I want you to take really good notes here. And of course, we will always come back together. I will always take your questions so that I can clarify things for you. Okay, give me just one moment so I can share my screen. All right, so friends, again, page 341, way up at the top, we are going to be talking about Mrs. Chang's vegetable garden. Here we go. Mrs. Chang's vegetable garden is shown right here. It is shaped like a rectangle. She grows tomatoes in one part. She grows corn in the other part. What is the area of the garden? So you can see Mrs. Chang's garden. This is her garden. This is her garden. Her garden is divided because she grows two different vegetables. That's real life, friends. That happens all the time. So we have tomatoes, we have corn. So when we're close reading our problem, it is saying that she has tomatoes in one part, corn in the other part. What we want to know is the area of the garden. That's the big important piece. This is what I'm asking you. What is the total area of the garden? There are different ways that you can approach this. There are different ways. What I like to do is take it one section at a time. I'm going to take it one section at a time. So this is going to be tomatoes. That's going to be section 1, or my first shape. And then I'm going to look at the corn. That's going to be my second shape. So down here where it says try it, this is like my workspace, right? So number 1 is here. I'm going to find the area of the tomato section first. So here we go. I know that area equals length times the width. I do know that my garden is 5 feet long. It is 3 feet wide. That's my tomato part. So my area is going to be 15 square feet, or 15 feet square. So that's number 1. I'm not done, of course. Now I need to go up to number 2, which is corn. Ooh, I love corn. Can't forget about the corn. Here we go. And what do? Do we start again? We absolutely do. We step it through, friends. We never shortcut. We do the work. Area equals length times the width. On this second part, I know that the corn part is 5 feet long. But, oh, look at this. Look at this. I do not have the width for the corn. Or do I? Or do I? Just because, friends, it is not identified here doesn't mean that it's not identified elsewhere. You can see that the width for the tomatoes, the width for the corn, it's the same, even though it's not explicitly identified or written down. Do I know that this is 3 feet? I absolutely do, because it's the same width as the tomatoes. So can I put that there to help my brain? I sure can. I sure can. So I can say again, area equals length times the width. I have, oh, I'm sorry. Oops. That's 4. That's 4. I'm sorry. The corn is 4 feet in length. My apologies. 4 feet in length. And 3 feet in width. And that, of course, is 12. So this area equals 12 feet squared, or 12 square feet. Again, my apologies, friends. Working on corn there. I'm very sorry if I confused you. So again, we've got the tomatoes. That section is 5 by 3. We've got the corn. That section is 4 by 3. But we are not done, friends, because I need the area of the total garden, not one or the other. So what do I have left to do? Now it becomes an operation of addition. I need to take my 15 square feet for the tomatoes, the 12 square feet for the corn. I need to add them together for a total of 27 square feet. 27 square feet. Why? Again, because I added this area to come up with the total area of the garden. All right? Now, this, friends, is something we're going to review, because this is another way to look at it. So instead of taking each of these parts, the 5x3 and the 4x3, there are students who can see, or what we call conceptualize, that this is in fact one garden, and we have all the measurements that we need to do a simple area equals length times the width. How? I'm going to show you how. So let's go ahead and I'm going to separate this for you. This is another way to do it. I could take equals length times the width. And notice how I'm always writing down the formula in my brain. Why am I doing that? I'm doing that to remind myself what it is that I'm looking for and what I need to fill in. I'm looking for the area. In order for me to do that, I need the length times the width. I need those measurements. Now, friends, here's one way of looking at it, but look at the other way. Instead of that, you could take the total length and use that in your formula. And I could say that the area equals 9 feet. Why? 5 plus 4. The whole garden together, 9 and 4. The width remains the same. So my area would be 27 feet squared. And you will notice that in that match. So again, what did I do? I took the total length of the garden. I didn't do tomatoes, corn, tomatoes plus corn. I did the whole garden length, 9 in total. 9 in total. The width, of course, remains the same. I'm still getting 27 square feet or feet squared, and you can see that it matches when I did the sections separately. Okay? I will give you just a minute to get those notes written down. All right, now we are going to take a closer look at page 342. 342. Up at the top, we are going to continue to explore different ways to understand the area of Mrs. Chang's vegetable garden. So up here, you're going to see that her vegetable garden is shown. It's shaped like a rectangle. So again, growing 2 different vegetables, we want to know the area of the garden. This is another way you can picture it. So let us go back to what we call our arrays or our tiles. You can use square units to find the area of each small one, and then you add them together. That's what we did, except now you're tiling it and you're adding them all together. You're tiling it and you're adding them all together. So again, 15, or 5 multiplied by 3, and then 12, or 4 multiplied by 3. You can see 15 and 12. Again, that is our 27 units. Okay? Or in this particular case, we know that it was measured in feet. We always use the unit of measurement if we have it. Okay? And again, down here as it's modeled, you could use the entire length of the garden and multiply that by the width that doesn't change. Two different ways of looking at it. Two different ways to model it. And some of you are quickly seeing here that this is an array, that we have 3 groups of 9, right? Or we have 9 groups of 3. Again, friends, we are going to be taking a look at that commutative property of multiplication. 9 groups of 3 or 3 groups of 9. The product, of course, remains the same. Okay. All right, let us take a look at page 343. 343. I'm going to try to connect this a little bit for you. All right. So now you can use that problem from the previous page to help you understand how to add the areas. So it says to look at that model again. The equation is 9 times 3 equals, we have a question mark, is used to find the area. Explain what each factor stands for in the equation. All right. So you can see here, and of course I would write complete sentences, but out of the interest of time, I will just quickly identify it for you. So we could call that the width, and we can call that the length. And in number 2, it says the picture of the garden and model, it shows the length broken into 2 lesser numbers. What are the numbers? And of course, we found that with the tomatoes, it was 5. With the corn, it was 4. Okay, and then it says you can use these numbers to find the areas of the 2 parts of the garden. Always refer back to those models if you need to. So of course we have tomatoes, and that's going to be 15. And then we have the corn, and that was 4 times 3, again, length times the width. And this is feet squared, and this is feet squared. And so now, of course, you can add the areas. You are going to have 15. You're going to have 12. And that's going to be, again, 27 feet squared. And again, down here at the bottom on number 5, explain how you can find the area of a rectangle by adding the areas of the 2 smaller rectangles it is made from. So again, friends, you're applying the formula area equals length times the width to each part, and you are adding them together. Okay? I'll give you a minute to make sure you have all those written down. And then we're going to come back together and we're going to take any last minute questions.